So, same technique, 1 over the determinant times the transpose of the matrix of cofactors. So what do we have to find first? The determinant. Okay, now, I'm going to do this one by cofactor expansion. I'm going to pick a row or a column. That's going to make this pretty easy. I'm going to expand on I'm going to do the last column. I'm going to do the last column because it has a couple of 1s. They're both positive, and it has a 0 in it. Now, does it make any difference? Doesn't make any difference. It's completely personal preference. Okay, as long as you do it correctly and get it right, then there's no problem. So, whoops, determinant. So here's what I'm going to do. I'm going to expand along this last column. So I'm going to look at that position right there. What's the sign associated with that position right here? Positive. Okay, what's the number that's there? A 1. And then I'm going to write down what its minor is. Its minor is -2, -2, -3. Sign associated with this position? Negative. What's the number? It's a 1. Okay, and its minor is 1, -1, -2, -3. The sign associated with that position is positive. The number that's there is a 0. So I'm not even going to bother writing that stuff. I'm just going to figure out what the determinant is. So this is a 1, and then I've got a 0 minus a 4. I've got a -1, and then the determinant of that 2 by 2 is a -3. Write the minus 2. So I end up with, let's see, this is -4, and then that's going to be, so that's going to be +5. Ooh, that's good. Why is that good? Okay, it's good when it's 1. Why in particular on this particular problem where we have to find the inverse of that matrix, is it good when the determinant is 1? Means there's no denominator. Okay, it means 1 over the determinant is still 1, right? So we've got 1 over 1, so that's 1 over the determinant, and now we need to find the transpose of the matrix of cofactors. So let's find the cofactors to start with. With me? Okay. Let's see. What's the sign associated with this position? So this is a fairly long process. Takes a while. How many determinants do we have to find?
9.
We have to find 9. We have to find 9. Okay? So I'm going to find the determinant of that little guy right there. What's the sign associated with this position? Positive. Now, I don't care how you keep track of this. Okay? I can erase this. So I'm just going to put a little plus there just to remind me. And then I'm going to find the determinant here. So that's going to be 0 minus -3. So what number am I going to put here? I'm going to put a 3, and it's positive. I just put that there to remind me. So that's going to be a +3. Any questions there? So the sign associated with this position is positive. I cross out the row and the column. This is its minor. And if I put the right sign in front of it, that's its cofactor. Okay? You with me there? You sure? Because we got to do this 9 times. If you don't get it the first time, you're not going to get it on the other 8. We're good? Okay. All right, so I'll erase this stuff. What's the sign associated with this position? Negative. I cross out the row and the column, and I look at this. Okay, I've got a 0 here, and then a -2. So that's going to be a +2. What do I put right here? It's just a -2. You with me there? Okay. Sign associated with this position? Positive. I'm going to put a little positive there just to remind me. Cross out the row and the column. That's the little determinant that I'm going to find. So I get a 0 minus a +4. So that's going to be a -4. So what am I going to write here? Okay, I'm going to write a -4. I'm going to erase that. Okay, when I cross out the row and the column, hold on, right. And we're going up, upward diagonal. So there are 3 negatives there. It's Thailand, Southwick, everybody. Okay, let's take a look at this one. Sign associated with the position? negative. Okay, now its minor is right here. It's the -1 and the 1, the 0 and the -3 and the 0. So 0 minus a -3, so that's a +3. What do I put right here? It's got a negative in front of it, so that's going to be a -3. Sign associated with this position? Positive. Cross out the row and column. 0 minus a -2, so that's going to be a +2. We can hear you. Sign associated with this position? Negative. Cross out the row and the column. -3 minus 2. -3 minus 2, right? So that's going to be a 1, and there's already a negative in front there, so that's a -1. Now, see how many, think about how many arithmetic problems you have to do in order, and you got to do them all correctly in order to get this right. Is that -1? Is that correct?
Not right. It's -3 minus 2.
Okay. Hold on. Cross out the row and column. That's a -3.
Minus.
That's a minus. There are 3 negatives there, right?
But you see, yeah.
Right.
So it's negative. So it's -3.
So it's
-5.
Thank you very much. It is. You see how easy it is to make a little mistake like that. When I multiply here, I get a -3. When I multiply up here, write down the minus and then write down what number it is. It's -2 times -1, so that would be 2. If you try and do all of these calculations in your head, on this one right here, if this were a test question, I definitely would have written that one down. Okay? If you have to do a bunch of little arithmetic off to the side to make sure you get it right, please do. It's so easy to make a little mistake. And you've got so many calculations, you've got to make sure you get all of them right. So that 1 is wrong.
Because you mess up on purpose.
Okay? Okay. What do we get for the minor? We get a -5. What's the sign associated with that position? Negative. So what do I put right there? Put a +5. Got all those signs floating around, all those little arithmetic problems floating around. Got to make sure you get them all right. Okay, sign associated with this position. That's going to be positive. It's always a little bit easier when it works out that way. Cross out the row and the column. -1. That's going to be a -2, so that's going to be a +2, so that's going to be a +1, so I put a 1 here, right? I'll let you figure it out. Don't say anything out loud. It's got a 1 in it, right? The only question, is it positive or is it negative? It is negative. Why is it negative? Okay, because of the position, not because of what the little minor was. Okay, cross out the row and the column. Okay, sign associated with that position is positive. Again, putting a little reminder there's probably a good thing. That's going to be -2. That's going to be a 0, so we put a -2 there. Okay, now I'm done with all the hard calculations. The rest of this is pretty easy. What do I have left to do?
Nothing, because it's a 1.
Got to do this transpose thing. Okay, got to do a right-hand pancake flip. Now, remember I showed you this yesterday. If you slide your right hand underneath there and flip it over like that, keeping it kind of on a diagonal like this, that diagonal stays exactly the same. So it's all in the same place. So this is a 3, a 2, and a -2. This little upper triangle right here gets flopped with this one down here. Okay? So this is going to be a -3 here, a 1 here, and a -1 there. And this is going to be a -2, a -4, and a 5 here. Okay, that's the transpose of the matrix of cofactors. Out in front, we have 1 over the determinant. Does that matter on this one? We don't have any fractions to distribute through. The scalar sitting out front is a 1, so the answer on this problem is 3, -3, 1, -2, 2, -1, -4, 5, and -2. There it is. Okay? Any questions? I would at least take a look at the book and show how they had look at how they show how to find the inverse of a 3 by 3. It's a huge pain. So now we're going to solve a couple systems of equations. Okay? All right. So the first thing we want to do is we want to find a matrix equation for this. So remember what you do. You write down the coefficient matrix. So that's going to be a 1, a 1, a 1, and a negative 1. You write down a variable matrix. So we write down x and y. And over here I write down 8 and 4 for the answer column.
When did we do this?
We've solved this one. This is going to be, I think, the 4th time we've solved this one. Okay. Here's what we want to do. This is the structure of this problem. This is just like solving the problem where we had 5x equals 30, and I said we want to solve this without dividing. We want to do this by multiplying. So I could multiply this side by the inverse of 5, and multiply this side by the inverse of 5. The inverse of 5 times 5 would be 1, so I get an x over here, and then I have 5 inverse times 30. Now that's a really silly way to do that problem, but it's a nice way to do this problem right here. So here's what we're going to do. I'm going to find out what the inverse of this is. So let's find out what the inverse is of 1, 1, 1, negative 1. Okay? So if I find the inverse, it's 1 over the determinant, negative 1, minus 1. So that's 1 over negative 2, correct? Now, can we do this the quick way? Okay. What do we do with this diagonal going downward?
Keep it. Switch signs.
Okay, change signs. Okay, so this is going to be a negative 1, and this is going to be, or change places. Okay. The other one changes signs.
No, that would change your side. Yes, I know what you're saying. Sorry.
This is a negative 1, and that's a negative 1, right? You with me there? Okay, that's the inverse. So here's what I'm going to do. I'm going to take the inverse, negative 1/2, and negative 1, negative 1, negative 1, 1. And I'm going to multiply it by this guy right here. Now I'm going to show you how this works, and then in the long run I'll show you what we end up doing. Now if I multiply this side by the inverse, I'm going to do the same thing to the other side. So I'm going to multiply it by negative 1/2, negative 1, negative 1, negative 1, 1, and that answer column, 8, 4. Okay, see the black stuff there? That was the original matrix equation. So this and this, that was the original matrix equation. And all I've done is I've multiplied both sides by the same thing. If I multiply both sides by the same thing, it's still a true equation, right?
Yeah.
Okay, so again, you don't have to do this every single time. I'm going to show you a little bit shorter way to do this. This is showing all the work and why it works the way it does. So I want you to take a look here. If I were to multiply these two together, first of all, can I multiply these two matrices together?
Yeah.
This is a 2 by 2, and that's a 2 by 2. If I multiply those together, what do I get? I get a 2 by 2. Okay, so let's write down what the 2 by 2 is that I get. I'd karate chop the first row with the first column. So this is going to be negative 1 and negative 1. Put those together, I get negative 2. Okay, let's do the next one. First row, second column. First row, second column. I get a negative 1 plus a 1. 0. Second row, first column. Second row, first column. That's a negative 1. That's a positive 1. What do I get? I get 0. Okay? Second row, second column. Take the second row, multiply it by the second column. So that's a negative 1. And that's a negative 1. So I get negative 2. Now what number was sitting out front? Negative 1/2. So if I were to distribute that through, here's what I get. I get 1, 0, 0, 1.
Which is
Okay, hold on. I just did these guys right here, and I got the identity matrix, right? So I did -1/2 times the two of these multiplied together, and I got the identity matrix. So that's going to be times xy. And then let's do the other side here. Can I multiply a 2 by 2 by a 2 by 1?
Yes.
Yes, I can. What do I end up with?
2 by 1.
I end up with a 2 by 1. Okay, so I'm going to have a 2 by 1, and we're going to have a -1/2 sitting out in front. So this is going to be first row, first column. First row, first column. So let's see, that's a -8, that's a -4, so altogether -12, right? And this is second row, first column, second row, first column. That's a -8 and a +4, so that's going to be a -4. Am I right? Okay. So when I multiply those together, if I distribute that -1/2 through, I get a 6 and a 2.
Can that just be the answer?
It is the answer. So I want you to take a look at this. What happens when I multiply by the identity?
You get xy.
You get xy. You get a 2 by 1 that's supposed to be equal to 6, 2, which is also a 2 by 1. What's the only way the two of those could be equal?
If that's a 6 and that's
If
a
x
2.
is 6 and if y is a 2. Now, we've solved that. Again, I think that's probably the 4th time we've solved that particular problem. Now, in practice, here's what we do. Because this side is going to work out the way we want every single time. It's like multiplying by 1/5. You know that's going to turn into a 1x. So we don't ever do this side. We just figure out what the inverse is, and we multiply the other side by that. We multiply the answer column by the inverse. Okay? So on this problem right here, let's figure out so let me draw this line right here. Let's figure out what the coefficient matrix is. Coefficient matrix is -1, 2, 7, and 7. So I'm going to call that the matrix A. Let's find out what A inverse is. So I've got to figure out what the determinant is. -7 minus 14. So the determinant is -21. So I'm going to have 1 over -21. Okay, now don't say anything out loud, just start writing. Remember the shortcut to finding the inverse of a 2 by 2? This diagonal, they just switch places. So this is going to be a 7 and a -1. On this diagonal, whatever their old sign was, they just changed signs. So in this case, it's going to be a -2 and a -7. Now, are there any questions? Okay, so this is the inverse. All we have to do to find the answer is take A inverse and multiply it by the answer matrix. -4 and 12. That's all we have to do. So let me write down what we've got to do. We've got to take -1 over 21, 7, -2, -7, -1, and I've got to multiply it by -4, 12. Now, if you want to grab a calculator, some of these numbers are fairly large, but let's go ahead and multiply these together and let's see what we get. I'm going to have -1 over 21 out front, but notice I've got a 2 by 2 times a 2 by 1. I'm going to get a 2 by 1. First row, first column. So I take the first row, multiply it by the first column. So if I do that, I end up with, well, let's see here. That's -28, -28 minus 24. 52. Second row, first column. So that's going to be 28 minus 12. That's going to be 16. So if I distribute that scalar through, I get this. I get 52 over 21, and I get 16 over 21. One of those reduces, the other one doesn't. Let's see, 15 over 21. 3 goes into both of those, don't they? No?
Yeah.
7 go into them? I don't think they reduce. So there's our answer. That's our answer column, and it's equal to xy. So what's x? 52 21st, and what's y? 16 21st.
Isn't it negative? Yeah.
Oh, it is negative, thanks. Thanks. Yep, bottom one's negative. Any questions? Okay. All right. So this is called a matrix equation. We're solving that using inverse matrices. Is there ever a time where this wouldn't work?
Yes.
Okay, when the determinant equals 0. Okay? The determinant equals 0, just like Kramer's rule. Kramer's rule won't work, and you'd be stuck using row operations, at least from this chapter. Okay, any questions? Okay, I'm going to get rid of that problem right there, and we're going to solve this last one. We're going to write down the matrix equation. So the matrix equation would be, we write down the coefficient matrix, 1, 1, 0, negative 1, 3, 4, 0, 4, 3. What's the variable matrix in this case? X, Y, and Z. And then the answer column is 3, negative 3, and 2. Any questions there? Okay, here's what the answer is going to be. The answer is going to be X, Y, Z is going to be equal to some inverse matrix times 3, negative 3, 2. So all we need to do is figure out what that inverse matrix is, multiply them, we've got the answer. What matrix do we need to find the inverse of?
That big one.
That one right there. Okay, so that's what we want to find the inverse of. So if that's A, we want to find A inverse. So let's find the determinant. First row probably would be the best. So we're going to have a 1, 3, 4, 4, 3. We're going to have a minus 1, a negative 1, 4, a 0, 3. And we're going to have a 0. Don't need to worry about that. So this is going to be 9 minus 16, negative 7, and then minus, that's going to be a minus 3 and a 0, so that's going to be a plus 3. So negative 4, is that all right? So the determinant is negative 4. So that means we've got 1 over negative 4. We've got to find the matrix of cofactors and then transpose that. Okay, I'm going to give you like a 10-second head start on each one of them, and then I'll write down the number that goes there. What is it? What goes right here? First row, first column. What is it? Negative 7. Okay. Do the next one. What is it? Positive 3. Those are the two that we just did. To find this one, the sign that we'd put in front of it would be positive. Cross out the row and the column. You'd be left with this one right here. This is going to be a negative 4. minus 0. So it's a negative 4 that we're putting here, and the sign associated with that position is positive, so it is a negative 4. Got it? I'm going to put a little negative there to remind us that that position is negative. Cross out the row and the column. The minor's a 3. 1 times 3 minus a 0. So we've got a 3. I'm going to put it there, and it's got a sign associated with it. It's a negative. So the number that I put there is negative 3. Give you a head start on this one. What is it?
3.
It is a positive 3. Let's do this one. Quick reminder, that position, the position itself is negative. Doesn't have anything to do with the number that was there. The position itself is negative. Cross out the row and the column. What is it? It's a negative 4. Let's do this one. It's a 4. Let's do this one. It's a negative 4. And the last one? Okay, cross out the row and the column. So the sign associated with that position is positive. This is going to be a 3 minus a minus 1, so that's going to be a plus 1. So it's a 4. We're putting a positive 4 there, and the sign associated with that position was already positive. So there we go there. Okay, are there any questions? Okay, I then need to take this and I need to transpose it. So here's what I'm going to do. Instead of writing it down twice, I'm going to move it up here and do it all at one time. I'm going to put the negative 1/4 out front, because I could go through and distribute through and I'd have a bunch of ugly fractions to work with. Remember the other day when I said if you leave it out front, if you have to use it again, that's not a problem. So I'm going to move that up here and I'm going to transpose it at the same time. So that's a negative 7, a 3, and a 4 here. Then I've got a 3, a negative 4, and a negative 4. And then a negative 3, a 4, and a negative 4. Okay? Now double check me, have I made any mistakes? Everything look okay? Diagonal looks the same. I took these two and switched them. I took these two and switched them, and I took those two and switched them, so they didn't really switch because they were both negative 4s. Okay, now, that's quite a few calculations right there. Hopefully that is a little less overwhelming than it was maybe 20 minutes ago. But let's take a look at this. This is a 3 by 3, and this is a 3 by 1. Whoops. Said 1, wrote 3. Is that as awful as it looks?
No.
It's really not. We're going to have this negative 1/4 sitting out front, and all I need to find is those 3 numbers right there, and that's what my x, my y, and my z are going to equal. So let's figure out what these are. First row, first column, I'm going to take the first row and multiply it with the first column. So that's going to be negative 21 plus 9 plus 8. What is it?
Negative 4.
Second row, first column. Second row, first column. So this is going to be a 9 minus a 9 minus 8. So it's negative 8. Third row, first column. Third row, first column. So that's going to be a negative 12. That's going to be a plus 12. So those cancel each other out. And this is going to be an 8. So if I multiply through, I get x, y, z on this side. And then on the other side, if I distribute that scalar through, I get a 1, I get a 2, and I get a negative 2, right? So 1, 2, -2. There's my answer right there. Okay? All right. Any questions? Okay. All right.